Hello, welcome to Introduction to Java Programming. In this session, we will discuss about the inheritance, especially overriding, polymorphism, and related stuff. Let's begin. In the last session, we have understood what is inheritance, what happens in the inheritance, uh, what all will get inherited and what will not get inherited. So those all details we have seen with a simple example, right? So we have created a class called employee. In the employee class, we have data members and one setter and one disk method. And a tech employee, simply by saying extends, it can acquire all the non-private members and we could able to create an object, right? So let's continue with the same. Yeah. So when there is an inheritance among classes, a subclass can acquire all non-private members of its superclass. This part we have understood, right? Now let's also understand the remaining two. One is it's having its own members, and the third is redefining the behaviors. So while redefining the behaviors, we require to know about another object-oriented programming principle, that is polymorphism, and we will discuss about that, and we will understand what is overloading and what is overriding. So these concepts we are going to see. But before that, let's understand this. How a child class can have its own members and what happens. Okay, so now here my child class has nothing, uh, nothing except it is actually getting few things from its parent, right? So this we have understood and we have created an object, etc., etc. Now, so time being, let me actually have something else also here. Yeah, first let me add actually a method in my parent class. Okay, so here I'm going to add one method in the parent class. Since I have a basic, right, that is actually the basic salary, I would like to find the full salary of an employee. So total salary of an employee, because just we are mentioning a basic salary. On basic, few allowances will be there actually. And so when you have these allowances combined, then we will actually get the full salary. So for that, I will have a method that is a public void calculate the salary. Okay. So how to calculate the salary? We assume a few details actually. See, usually the allowances, what are the allowances we will have? So I am declaring them as local variables. The standards, we will actually take it for any salary. Yeah, so there will be certain DA. So I am giving the percentage actually. So some DA percentage, let's say some 42% is there. And of course, some HRE also will be given. The HRE is, let's say, 30%. And some transport allowance is also there. Let's say some 8%. Okay, see, these are all the allowances which will be calculated on the basic salary. Okay, so now I want to find the final salary actually, because my salary is double value, my basic is double value. So what I'm doing is double salary equal to, so how do you find the total salary? So you have the basic salary, and on top of the basic salary, you will have all these things. Basic into 42%. Okay, so basic into 42 plus this 30 plus this 80 actually. Okay, so these are all the allowances. Sorry, 8. So total actually 80% it will happen. So basic plus basic into this much. Okay, and divided by 100, because these are all percentages, right? So this much 80 by 100. So this is how the salary is calculated. So you have a basic plus on basic you have certain allowances. So total you have 42 plus 30 plus 8. What is this 42? 42 is DA. Yeah, and what is this 30? 30 is HRA, and this is a TA. Divide by 100, and it actually multiplies with the basic, and you will get certain salary. And this salary I would like to print. This salary I would like to print. So total salary, okay, equal to total salary equal to this particular salary. So this is a method. Okay, so this is a method. Now let me actually show you that. So this will get compiled and this method also will work. So in order to do that, let me actually compile this initially. Java C emp.java. It's compiled, right? So now I will go to my driver class. So where I have E1 equal to new employee and the basic is given. So now I can also call this particular E1.cal salary. Okay, just to make sure that my parent class is fine and it is working good, then I will inherit. So now Java C driver dot Java. Yeah, it's worked actually. And when I run driver, now I will also see the total salary. Yeah, now you can see when the basic is 86,000 and your total salary is becoming 1,54,980. So that means 86,000 on top of it, you have 80% of the allowances. So this will be the total salary. So this is how it actually works. Now my parent class has got one more public method. And now what happens here, the tech employee, when I say public class tech employee extends EMP, I will actually get all these public methods. Okay. And of course, I have the constructor, which can be accessed super. I could go and get it. I can create an object and I can get the salary also. Right. So for example, if you want to create an tech employee object, I can do that actually straight away, like how I did earlier. Tech employee T equal to a new tech EMP. This is the default constructor, but default constructor has a super constructor getting invoked actually. So T dot set EMP. Now you can actually set some values like 321 is employee ID, HDF is the name, and let's say 99,000 is actually, let's say, the basic. Now you can actually display T dot DISP and T dot cal salary as well. Cal salary as well, right? So just by extending, just by saying extends, I'm getting everything of it, and all these things are possible actually. So that's the beauty of inheritance, and that we have understood. Let me compile this one also. Java C techemp dot Java. Yeah, compiled successfully, nothing wrong over there. And Java techemp. Now I will get the salary also, right? So total salary is 1,78,000 because total salary is 1,78,000 because you have got this 80% of these allowances. Okay, so for example, if I give this is like 1,23,000. Now let me actually compile again and see what will be the salary. Okay, compiled successfully. And when I say Java tech employee, so now the salary, total salary will be like somewhere around 2,21,000 with 80% of the allowances. Fine, so it is working, right? So it's working. Now what I do is, same thing is fine. Actually, I have this class is available. I will extend it. But now child classes, see, child classes can have its own members. Now, since technical employees and a technical employee is a specialized employee from the generalized employee class. Why I require this technical employee class? Because something else is there for the technical employee class, which general employee doesn't have. Let's say, let's assume technical employees will be given certain bonus. Technical employees will be given certain bonus. So now into bonus, right? So now I have a setter for the bonus, right? I should have a setter for the bonus. Okay. So I have to write the set bonus method. So how to write the set bonus method? So public void set bonus. Now I have to set the bonus value. So this is int bonus and this dot bonus equal to bonus. So technical employees will be given a separate bonus. That's the point actually here. So that's why I require a specialized class, that is technical employee. Fine. Okay. So now when I actually have technical employee object created, I am creating with here I am creating with what? EID is there and EID, ename and basic, right? So this is what actually gets created with the defaults with the super call. Now I am passing set employee. So now I have to pass T dot set bonus also. This is my own class, so I can actually bonus. So every technical employee, let's assume they will be given a bonus. they will be given the bonus actually. Okay, so let's say 10,000 is the fixed bonus for every technical employee. Fine. So now you have a setter. Now you have a setter. You want to display the bonus. Now you require a get bonus method also. So now you can write a void get bonus, make it public, because usually we have to make things public, right? So public void get bonus, and here just print the bonus. Print just bonus value. You won't say bonus equal to space, and then I am saying bonus. Yeah, so that's perfect actually. So I am setting the bonus, and after displaying, I am actually displaying the bonus as well. So that is actually get bonus method. Yeah, so now what has happened along with the inherited members? So here I have some inherited members. So what are the members? All the public members, right? All the non-private, otherwise not public, non-private members. So those are actually the methods, 3 methods. Right now, child has its own members actually. So how many members? Child has child specific members. These we call as a child specific members. So we have child specific members as well. Of course, so there is only one member, and in order to set, we have a setter for that, and you have to get this, we have to getter for that. Right. So as per the inheritance, a child class can have its own members. Now I have my own members, 1 data member and 2 methods actually. Now we can create a technical employee object, and then we can call the set employee. Okay, and then we can set the bonus as well. Then we can call display, we can ask for display, and then finally we are saying calculate salary. Right. So this is about the second point. So proving the second point. So it can have its own members. So now let me compile this. Yeah, compiled successfully. And when I say Java Tech EMP, then you can actually see the employee details are getting printed along with the bonus. Actually, this is the bonus. Okay. And of course, the total salary for the basic 99 to 1,23 somewhere this one actually. Right. So this is actually working, right? So in inheritance, a child class can acquire all non-private members and can access the parent class constructors using super. We'll discuss of that one in detail, of course, in the next session. And the child class can have its own members. So that is clear actually, right? So this is clear and this is working. Okay, so now let's also understand the third point actually here. The child can redefine the behaviors. The child can redefine the behaviors of the parent class. Okay, so from the parent class, you are acquiring certain methods and you can redefine it. So this redefinition is also called overriding. This redefine is also called overriding. So what is overriding? Overriding is a polymorphic feature. What is polymorphism? That we need to understand. So polymorphism is one of the object-oriented principles, and this will come mostly whenever you have inheritance. Of course, without inheritance also you can have. That is actually called overloading. What is basically a polymorphism means? Polymorphism means the ability to take more than one form. A method or a constructor taking more than one form. Okay, so we have discussed this already in the previous sessions whenever we are discussing about constructors. Constructor overloading is there. Method overloading is there, right? Using this constructor with the default values and with parameters is a constructor overloading. Using the same named method with different parameters, different types, and different order, that's called method overloading. We have understood actually. So that is a polymorphic feature, the ability to do many things actually. So same method is doing different things. Same constructor is actually doing different things. Okay, so that is actually method overloading, that possible with method or a constructor, and that happens within a single class. Next, we have something called overriding. So this happens whenever you have inheritance. Whenever you have inheritance, then only it is possible. It happens in multiple classes whenever you have inheritance. So what is overriding? Overriding is actually is a process. We can define something like this. It's a process where where a subclass can redefine the behavior of the parent class. Redefine the behaviors of parent class methods or superclass methods. Since I am saying subclass here, I can say superclass methods, right? It's a, overriding is a process or a mechanism where a subclass redefines the behaviors of superclass methods. So now, what is the scenario actually when this overriding is going to happen? So now let's actually see here. Okay, the same example. Here I have a cal salary method. Here I have a cal salary method. It is calculating the total salary, right, of an employee. That's fine. Here for employee, basic is there and certain allowances are there, local variables as allowances. Okay. So now coming to this technical employee, we have a bonus as well, right? We have a bonus as well. Now, if you find the salary of a technical employee, the salary should be including the bonus, right? Whenever you process the salary, a technical employee should get the salary inclusive of the bonus. But here, we are not getting the salary inclusive of bonus. Let's see here. Separately, bonus is getting printed, but salary is not actually added with the bonus, right? So now, there is actually a necessity, there is a need actually to override, to redefine the behavior of cal salary method. So here we are actually having cal salary method. Now we need to redefine the cal salary method because the salary that we are calculating, we are not including the bonus, right? So finally, to process the salary, find salary method is called, and here when the find cal salary method is called, you are actually getting a salary just with the allowances, but not bonus is not included. So there is a need to redefine it. So that redefinition of a method in the child class, redefinition of a parent class method in the child class is going to be called as overriding. So now we redefine it. So what we do is I just take this and put the whole of the thing here in my child class. Okay. So here what I'm doing, I am redefining the behaviors. Redefining the behavior. Okay. So what I want all these local variables, but I want to find the salary. Salary equal to basic into basic plus this one plus bonus. Yeah, the bonus value should get added to the salary. This is the updated salary, right? For the technical employee, we have to redefine this because my salary is not actually considering the bonus. Now there is a need to redefine it. This redefining is actually called as overriding. This is called as overriding. Overriding allows a subclass method to redefine the behaviors of the parent class method. So here, whenever you are redefining, you have to see that the signature is same. Method signature is same. This is important. Method signature must be same. Okay, in overloading, method signature should be different. Parameter should be different, type should be different, order should be different. But in the overriding, method signature must be same. So that's why just I copied there so that signature doesn't change, right? So here I am actually using basic plus basic into this much plus bonus. So I am done actually here. But if you compile, you will actually see some error. If you compile, there is some error that you are going to see. Where is that error? The error will be in the line number 18. Okay, so now let me actually show you that error. You can also guess that error, why that error is going to come. Let's see. So Java C techemp dot Java. Now you are going to get error in the line number 18. See, Lava line number 18, there is an error. Basic has a private access in employee. Yes. Basic has a private access in employee. So in employee class, you're using the basic, and this basic is a private member. And how do you, in the private member can be used in the same class. So I'm calculating it. But straight away, how I can access this basic here? I cannot access actually straight away. Right? We cannot access private members outside of a class. Now this line is actually a problem to me. This line is actually a problem to me. So how do I access the basic? How do I access the basic? So how do I access my superclass, a variable which is private? So there are two solutions for this. There are two solutions for this. So one solution is actually, what you can do is you can actually make your basic as protected. When you make that as a protected access modifier, so child classes can access. Child classes can access. Okay. Second one, since basic is required for the child classes to calculate the salary, you can actually write a getter for basic. You have to write a getter for the basic, right? So like this actually. So get basic, a method you have to write, and this method should return actually the basic value. Okay, we cannot access directly, but we can access through the getter actually, right? Write a getter and you can access it. So let me show you the first mechanism. So in the first mechanism, what I am saying, I am making, instead of private, I am making actually protected. When I make it protected, it's not fully encapsulated. It's not fully encapsulated, right? Because fully encapsulation means everything is private. So, but I want to pass this value to my child, so protected has to be used. You protect. So now I have made this protected. So now I need to recompile my employee as well because it got changed. So let me actually compile Java C emp.java compiled. Now let me compile my tech emp. Compile my tech emp.java. Now this time you see there is no problem. There's no problem because it's protected. Basic can be accessed. When I run tech emp, now observe actually salary. Now let's see the salary. What has happened? 123, 80% is somewhere around 221 plus 231 actually. So if you want clarity, what I do is whenever we are actually setting the data, we will actually set 1 lakh as the salary so that it is easy to identify, right? So now I will set this as 1 lakh. So 80% allowances, 1 lakh 80 should be the salary. But 10,000 bonus, so 1 lakh 90 we have to get it. So let me actually recompile this and show you Java C techemployee.java. And when I say, now you can actually see 1 lakh is the salary, 10,000 is a bonus. So total 190, 1 lakh 90,000, 1.9 lakhs, right? It's working. So now the salary was processed properly for my technical employee. Bonus is also included, right? So this is how we are actually overriding. This is how we actually overriding. So when you override, the method signature must be same. Okay. So since you are overriding, right, you can actually use one annotation called override. You can actually use one annotation. This is called annotations. In Java, we have annotations. So always you can use override annotation because you are overriding this method. You are telling the compiler, this method is my parent class method. I am redefining it. So that you can actually specify. Okay, so I will actually specify the use of this override in coming sessions. But whenever you are doing it, just tell the compiler that you are overriding this particular method from your superclass. Okay, so this is the first way we solved it by making protected. Okay, but sometimes what happens, we want fully encapsulation. So I don't want this to be protected. I want private only because I want to achieve fully encapsulation. Okay, I want to write a fully encapsulated class. So fuller access control, fuller data security. So now what you need to do, you need to have one getter also, right? You need to provide one getter also. So now getter for basic. So how to write? So public basic is double, right? So just return the double value, and the getter method is get basic. Okay, just provide it. So just say return basic. Yeah, whenever this method is called, basic is returned actually. This is a getter for the basic because my subclass requires the basic. So yeah, so here what I do, instead of whenever I require basic, right, I can't access basic straight away. I say get basic. Get basic. I call this method because this method is available to me through inheritance. All the non-private members are available through inheritance. Get basic is available to me, and here also I will have this get basic. This get basic method will return me directly the basic. On basic I am doing these arithmetic actually. This is the second way how we can actually get the data from your parent class. So since I changed both the classes, I need to compile both of them. First let me compile employee class. Now it has a getter, fully encapsulated class, and now compile TechEMP. Now I don't have a product member, but I am accessing the basic using getter. Now it's also compiled. So when I run actually TechEMP, then I will also see the output coming just like earlier. So I have the salary 1,80% allowances, so 1,80,000, bonus 1,90,000, right? So this is redefinition and this is overriding. So that's what actually I'm explaining here. So there is a polymorphism that will be associated whenever you have inheritance. Childs can redefine the behaviors of the parent. That is called overriding, and overriding is actually a polymorphic feature. A polymorphic feature where the method signature should be same actually. A method signature should be same. Now here I have one more thing also. If you see the output here, when I'm displaying, I'm actually displaying up to organization. Bonus, to display bonus, I have a separate method. To display bonus, I have a separate method over here. Right? I don't want to write a separate bonus method. I don't want to write a separate bonus method. Okay. I don't want to write a separate bonus method. But my bonus should get printed with the display method. So what I need to do, I have the display method available here, right? So let's redefine the display method also. Let's redefine the display method as well. So in the redefinition, what we do, in the redefinition of this method, what we do, after this organization, we will add the bonus. After this organization, we'll add the bonus. So public void disp, system.out.println, EID, ename, basic organization, right? So now what we need to do is I need to give a space and I have to add bonus. Okay, so this kind of overriding I want to do. I will say at the rate override. At the rate override. I'm reading and redefining the disp method also. But the problem here from your child class is how do you access get ID, EID? How do you access ename? Basic of course you can access. How do you access org? Because all these are private members. All these are private members. You cannot access it. So in order to access them, what you need to do, you need to have getter methods. You need to have the getter method. So in the employee class, you have to write a method called get EID. So get ename, get org. All getters you have to write actually because you made them private. So that's the use of getter methods. So we don't give access to our data directly, but we will actually write the methods. That's what encapsulation. Through methods we can access it. So straight away I cannot do it because I will have the same problem like earlier. So private access problem will be there. So now see, I will have so many errors because EID is not available, ename is not available, org is not available. So many errors. So I need to write getters, but I don't want to write those many getters actually. I don't want to write those many getters. Okay. So what is what is the other solution actually? What is the other solution? So the other solution is actually there that actually calls for the need for a keyword called super actually. So here I need to use a super keyword and I will explain that super keyword thoroughly. What I do here is I just say super dot disp. So super dot disp is nothing but parents disp method. parents disp method. Okay, by using super keyword, you can actually refer to your parent class method, right? So here what I'm doing, super.disp. So in the overridden disp method, I am making a call to my super disp. So that means it goes to the parent class, it calls my disp, and this disp can access EID, ename, everything. I am not accessing, I am just calling a method, my parent method using the super keyword. Okay, and it prints all the all the 4 members, and bonus is my child specific thing. So I am printing the bonus over here. So this is how we can actually solve this problem by using this. Either you write the getters, otherwise you can use super keyword. And to call the method, super keyword you cannot use to call the private members because private members are not accessible. Only the method you can actually call. So that's how we can solve and we can redefine the disp method as well. Now let me actually compile this. Now I don't have any problem. Oh, somewhere I am writing here get bonus. So this get bonus is not there now. The bonus method actually I have removed, right? That get bonus method I have removed here. So there is no get bonus. I am putting that bonus printing inside a new overridden method, that is the disp method. So that is the error actually. Yeah, I forgot to remove that. So let me compile now. So then here no errors actually. Okay, so let me now go and run this. Yeah, so now everything is working fine, right? Everything is working fine. So now if you see, these are all getting printed as part of the disp method. These are all getting as part of the disp method. See, I'm setting the employee, setting the bonus, then disp. When I say disp, all my EID, ename, basic, and organization from my parent class disp method is getting printed, and I have overridden behavior where I'm printing bonus also. Then when you say cal salary, the salary is getting printed. So this is about the overriding or redefinition actually. So with this, now we understood what happens in an inheritance, acquiring all non-private members, child has its own members, redefinition. Redefinition is about polymorphism and actually what happens in the polymorphism and what are different forms of the polymorphism and who will actually take place in the polymorphism. Only methods will exhibit the polymorphism. So hope you understand this. In the next session, we will discuss thoroughly about the super keyword and thank you for your time.